Before we move on to the next section, I wanted to talk about something that maybe I didn't explain so well in the previous videos. In each of my examples, you'll see that I start up the workers before I run the code on those workers. You could do the same in your code, but that's really for example purposes. You're probably going to be better off by running the parallel start workers in the startup program of your application. And what that's going to do is create a pool of workers that are going to stay in memory and available to run code in parallel for the duration of your app. Yes, that does mean that ParallelFox is using system resources while those workers are in memory. If that seems like a cardinal sin in your book, I ask you to consider a couple things. The first is that FoxPro's footprint is actually pretty small by today's standards. Just ParallelFox on its own uses about 3 megs of memory for each worker. And of course that's going to increase as your code runs. But if you compare it to something like a web browser or Outlook that may also be in memory, it's actually pretty small. And the second thing is that if you look at other parallel processing libraries, you'll see that they use the same pattern, whether it's threads or processes. There is a pool of workers that are kept in memory rather than instantiating and shutting down those workers with each call. The workers are kept in memory because you don't need to take that hit with every call. You're not going to want to be starting up FoxPro every time you want to run code in parallel, because that would be a pretty big hit on performance. So that's the general pattern that you see out there. Start up your workers, keep them in memory, run code on those workers as you need to. And at least in the FoxPro world, something else you need to consider is that there's going to probably be some environmental setup right after you start up the workers. That's probably the first thing you're going to do. So that might be as simple as setting a path or opening up some tables. Or in my case, I use a commercial framework. So setting up the environment involves instantiate the application object, running code that goes with it, reading in metadata that comes with the framework. It might take a few seconds to do that, and so if I had to run that code every time I wanted to run code in parallel, that would just basically kill it for me. So rather than do that, I start up my workers in my application startup program, set up my environment, and now everything is ready to run my code in parallel. And then when it finally becomes time to shut down the program, that's when you call parallel stop workers, and that will end the worker processes as well. So I just wanted to clarify that. Seen some cases where the start workers and stop workers were being called more often than it needed to be. I suppose if you just have one big process that you want to run in the background, it would be okay to call start workers, start your background process, call stop workers, if that's the only case where you're going to be running code in parallel in your app. But in general, you're going to want to make the parallel services available for the duration of your application, and that's the intention and design of ParallelFox. We've already seen how to run code on your workers in ParallelFox, and while that code is running, you might want your worker process to be able to communicate with the main process, or you might want your main process to respond to things happening on the workers. And those things are performed or handled by means of worker events. And ParallelFox supports several events. Let's take a look at our first event, the complete event. Here's a program that simulates some work and displays the status of that work to the user by means of a progress bar or a thermometer. So let's walk through the code. Up here we're just instantiating an object and calling the test method on that object. Here's the actual class where all of the code is. Here in the test method, we've just got a for loop here that calls a run units method on this same class that we'll look at in a second. But basically it's just telling it how many units of work to run. And that's I times 10, so in the first iteration it's going to run 10 units of work, the second iteration 20 units, 30 units, and so on. So since each iteration is running more units of work, you'll see that it takes longer for each one to run. And then we're also updating the progress for that. And then whenever we're done, we call update progress one more time to show that it is complete, and we display how long that process took. Let's move down to the update progress method, where we instantiate a thermometer if it's not already instantiated, and then we update the thermometer each time that it is called. And if this is the final step and it is complete, then we run the complete method, which basically closes down the thermometer. In a real program, I would probably do a better job of decoupling the thermometer from this class, but for example purposes, it's easier to understand it this way. And then here's our good old simulate work method and the run units method that calls that for the number of units that we're passing to it. We're also going to display on the screen that this is called for each iteration. So let's run this. And as you can see, it displays each time we start running the units, and as each one is completed, the thermometer is updated. And it does take a little longer between each iteration. Okay, so let me record that time. And let's see how we can handle this with ParallelFox. Okay, so let's do the usual stuff. I'm going to instantiate the parallel object inside my test method, start the workers. And I'm going to call the run units method on this class. And pass I times 10 as the parameter. So, and of course don't forget parallel weight. Okay, so let's go ahead and run this and see what happens. Okay, already at 100%. That was fast. Wait, are we done? No. Okay, that wasn't exactly what I wanted. The thermometer went straight to 100%, but it still took 8 seconds to run the code. Let's run that one more time and see if we can catch what's going on in the workers. So we're at 100%, but if I look in one of the workers, I can still see that it's running code. So what happened here? Let's take another look at the program. Okay, I see the problem here. In the original program, the progress was updated after the run units method was complete. In this case, ParallelFox queues each call that it's going to run on a worker. And so those calls are queued in less than a second, this code runs, and so that's why we're seeing it go straight to 100%. So how do we fix that? How do we tell our code or our thermometer to update after the run units method is completed on the workers? Well, the complete event is for that very purpose, and we are going to use parallel bind event method or function to run a method on our code when the complete event fires. And so we want to run a method on this class, and syntax is very similar to FoxPro's bind event function. And so what do I want to bind to? I want to update the thermometer whenever the code is complete on the worker. I suppose that would be the update progress method. But I'm looking at this and I see that it takes a percent in a message. At the time this fires, the main process doesn't really know what percent is complete, and the worker doesn't know either. It just knows that it's running some code. So I think what I really need is another method that's going to keep track of the progress for me. So I'm going to put a new property up here, and I'm going to create a new method here to increment progress each time it's called. That's going to be in okay, and then I'm going to move this code to call the actual update progress method and update the thermometer with the value in this in progress. Okay, now I'm going to go back up to my bind event and tell it to call the increment progress method. Just to go over this one more time, we're telling it every time the worker complete event fires, then we're going to call the increment progress method. That's going to add 10 units of work to the progress and then update the thermometer. Now, there's one other detail. The complete event returns the return value of the code that you ran on the worker. So if I go down to the run units method here, I see that I'm not returning anything, so it's just going to return true. But if I were returning a value from this method, it would come back with the complete event. So what that means is whatever event handler I'm binding to, it needs to accept the return value, even in the case like this where I'm not going to use it. So let's see if this runs how we expect now. Let's clear that. Okay, that looks better. As each unit of work is finished on the worker, the thermometer is updated at the time it's expected. And here we see it took 9 seconds compared to 21.2 seconds before. So that is the complete event. A couple of notes on that. FoxPro's do command does not have a return value, or rather it does not return a value. So when you call parallel do, the return value that comes back to your event handler is always going to be true. You still have to handle it because ParallelFox is always going to have a return value, but you can't return a value using the do command. If you do need to get a return value, use the parallel call function instead. One other note, and this applies to all events, if at all possible, VFP auto yield should be true, and that is the default. When it is true, FoxPro can interrupt whatever code may be running in the main process and respond to the worker event and run the code on it. If it is false, the main process cannot respond to the events until whatever code may be running at the time is complete. Now, about the only time you're going to change this is if you have ActiveX controls that require it. If that's the case, maybe you can set it to true just while your parallel code is running, and then set it back to false whenever that's complete. Or in a worst case, you can have code while your code is running in your main process. You can call do events force maybe at regular intervals, and that will cause FoxPro to go ahead and respond to the worker events when that's called. So those are just a couple things that you need to keep in mind while working with events. The complete event returns one value from the worker process to the main process when it's complete. But what if you want to get multiple values across? You've got multiple variables in your worker process that you want to get to your main process. Well, that's where the return data event comes in. And that has a variety of uses, but let's take a look at one scenario in particular where it helps us. This program is similar to our last example. In this case, rather than displaying a thermometer, we are timing each call to run units. We log those results, save those results in a table, and then browse that table at the end. So scrolling down to the run units, you can see here, this is where we log the number of units that were run and the time it took to run those units. And here in the log results method, we are creating the log table, opening it if it's not already open, and we set it to optimistic table buffering and log the results. And the save results is called at the end, and here we're using a transaction to go ahead and save the buffer data to a table. So let's go ahead and run that. And again, we're increasing the number of units that are run with each iteration, so it takes longer for each one. Okay, so there's our log, and we can see how long it took to run each number of units, and then a total time of 20.25 seconds to run the whole program. Okay, I've made the standard changes to my program, instantiated the parallel object, started the workers, and ran the call method function. But I still have an issue. If we come down to the log results, you noticed before that we're using optimistic table buffering, and then we're using a transaction to save the data. Now my workers are running in separate instances of FoxPro, right? So they can all write to the same table, but buffering and transactions don't cross those boundaries, so I can't have all workers participating in the same transaction. Now maybe that's okay, but in this case I've decided it's really important to me that all of the log results get committed as one atomic unit, and that's a common scenario. I don't want to lose that functionality, but at the same time I still want to take advantage of parallel processing, so I'm stuck. How do I handle that? Well, the answer is that I need to make the main process solely responsible for logging the results and committing the data. So to handle that, I'm going to bind to the return data event call the log results method whenever that event fires. So the event binding is set up, but I still need to fire the event. And to do that, I need to instantiate the worker object. And then here, instead of calling log results, I'm going to call the worker return data. So now the workers aren't even using the log table at all. So the worker fires the return data event, passing these two parameters back to the main process. Because of our event binding here, the log results method then gets called in the main process. The results are logged, and then save at the end, save results is also called in the main process, and the data gets committed inside of a transaction. So let's run that. And now my code is running in the workers. Should be done in a few seconds. Okay, there we go. So I was able to use parallel processing. I didn't lose my transactions, and we completed it in under 8 seconds versus 20 seconds. So that was a success. Return data event can be used in any case where you want to get multiple values from your worker process back to your main process. So what are some good uses of that? Well, maybe you've got a long process that's running in one of your workers. Maybe it's doing a search, or it's just processing some data, and you want to display those results as it's running. And you can use the worker return data to get those results back. It's not just for calling at the end of the process or the code that's running on the worker. It can be called multiple times. So then you've got asynchronous display of results in your main process while your worker is running. Another case is, suppose you've got you want to do multiple calls back to the main process using return data and pass a different set of data or different type of data each time. So it might look something like this. In your first section of code, you're doing in your worker, doing return data, value 1, value 2, etc. Then later on, you're returning a different type of data. 1, value 2, maybe it's got 4 values. So in that case, you can just make the first parameter you're passing, the type of data that you're passing, returning back to the main process. And then in your event handler that's going to run in the main process, it's going to accept these parameters, and then just have a case statement. Now that's a pretty obvious way to handle different types of data, but the reason I demonstrated is that you have just in effect raised your own custom event using the return data. So instead of type 1, we could have called this event 1, event 2, and then you can handle each type of event that you want to fire. Return data allows you to pass up to 26 variables back to the main process, which is the maximum number of parameters that FoxPro lets you pass. That includes pretty much any type of variable except for arrays. And the reason for that is that arrays have to be passed by reference, and FoxPro's bind event function does not allow that, does not allow variables passed by reference to be passed to an event handler method. So that's a limitation, but the way I like to think about it is that you can't return an array from a function or a program anyway, so it's basically the same kind of limitation. You can pass objects back if that helps you get around that, or you can always serialize it to a string and then deserialize it in the main process if you need to get a chunk of data across. So that's the return data event, and it can be helpful in a number of scenarios. One of the most powerful features of FoxPro is its built-in cursor engine. Every FoxPro developer knows that, right? It allows you to work directly with the data. It's super fast. It's just part of what makes FoxPro FoxPro. But whenever you want to go outside your instance of FoxPro, then things get a little more difficult. It's not something that's easy to pass around. And that's because the cursor is a specific data type, or data type that's specific to FoxPro, right? And it's not something that COM inherently supports. And that makes sense when you think about it. I mean, if you passed FoxPro's cursor type to VB6 or .NET, it wouldn't really know what to do with it. That's why you have to, if you want to work with other environments, you have to convert FoxPro data either to a ADO record set or XML or something like that the other environment can work with. In our case, we've got FoxPro on the main process and FoxPro on the workers. So if I want to get a cursor from my worker process back to the main process, I still have that COM boundary in the middle, and it's not something that's just naturally going to flow across. Fortunately, ParallelFox has a return cursor event that makes that process very easy and straightforward. This example shows one way we can take advantage of that. FoxPro has very good support for the SQL syntax. You can do some very complex queries, but sometimes you can't achieve what you want with a single query. You may need to run multiple queries and then pull the result from those queries into another query that provides the end result that you're looking for. And that's exactly what this example does. As you can see, I've got 3 queries that I'm running, and then pulling the results of those queries into another query. I've put each query into its own method, so if we run down to those, this is actually a very simple query just for demonstration purposes. So to make it simulate a long-running query, I'm actually simulating some work on the processor. And I'm doing that for all 3 queries, and then at the end here's the select statement that pulls them all together. So I'll run that now, and you can see how long it takes to run each of the queries. And there's our end result from all 3 queries, and that took about 11.3 seconds. Now, seeing how I have to have 3 queries here, wouldn't it be nice if I could run all 3 of those queries at the same time? ParallelFox will allow us to do just that. So here I've done the usual stuff, instantiating the parallel object, starting the workers, calling each of the 3 query methods, then I wait for those to complete, and run the final query. Now to actually return the cursor for each one of those, I need to instantiate the worker object and call worker return cursor. I can pass the name of the alias, but since I just want to return the current work area, I don't have to do that. So I'll do the same for the other 2 queries. And let's run it. Now the queries, all 3 of them are running at the same time on the workers, and there's our results in a fraction of the time, 11.3 seconds down to 4.2. Now notice that there is no parallel bind event here. ParallelFox automatically opened the cursor in the main process when the return cursor event fired from the worker process. So all I had to do was call parallel wait, and then that waited for all three queries to be opened, and at that point they were available for the final query. So a bind event may not be necessary, but I could still use it if I wanted to. So I can bind to the return cursor event and call the handler on this class. So I'll go ahead and create that here. And it has to accept the alias of the cursor being returned. And so if you needed to respond to or cause something to happen when a specific cursor is returned, you would probably do that here. In this case, I'm just going to print the program and the name of the alias that's returned. Other than that, the program will function like it did before. So I'll run that. And we can see here that as each cursor was returned, the event fired. For those that are interested, ParallelFox passes the cursor from the worker to the main process by writing the cursor to a temporary file and then reading that file in the main process. That is a little old-fashioned. At first I tried something a little more politically correct by converting the cursor to XML, but that just turned out to be too slow. Cursor to XML is fast, but XML back to a cursor is very slow when you're dealing with a large data set. So there is a small hit when writing to disk, as always, but other than that, you're getting the full speed of Fox Pro, and even returning a large number of records is very fast. That's the return cursor event, and another function that I'm sure you'll find very useful while using ParallelFox.